United States Air Force operates over 13,000 aircraft, which is more than the air forces of China and Russia and India and France and the United Kingdom combined. And we're not just talking about quantity, we're talking about a technological advantage so massive that American aircraft can operate in airspace that enemy fighters can't even enter. And here's what makes this completely insane, because the United States has more fifth-generation stealth fighters in active service right now than every other country on Earth has even built, including prototypes and test aircraft. And American strategic bombers can strike targets anywhere on the planet within hours. And American transport aircraft can deploy entire armies to the other side of the world and sustain them indefinitely. And the numbers are staggering, because the U.S. Air Force has over 1,800 fighters and nearly 300 strategic bombers, and over 800 tanker aircraft for aerial refueling, and over 900 transport aircraft, and thousands of drones and helicopters and support aircraft. And when you add in the U.S. Navy, which operates its own Air Force with over 3,000 aircraft, including carrier-based fighters, the total American aerial capability is larger than the next 7 countries combined. And here's the part that defense analysts find terrifying, because this isn't just about having more planes, it's about having aircraft that are generations ahead technologically and can conduct operations that other air forces can't even attempt. And during exercises, American F-22 Raptors routinely achieve kill ratios of over 30-to-1 against fourth-generation fighters, meaning one F-22 can defeat 30 conventional aircraft in simulated combat. And the question that military planners around the world obsess over is how the United States built an air force so overwhelmingly superior that peer competition seems impossible. And the answer involves 8 specific mechanisms that work together like a machine, where each component amplifies the others. And when you understand these 8 reasons, you'll see that American air power dominance isn't temporary or vulnerable. It's the result of structural advantages built over 80 years and continuously reinforced. And the first reason is something that started during World War II and never stopped. And that's the continuous industrial production of aircraft that has operated without interruption for over 80 years. And this created a manufacturing base and expertise that no other country possesses. And here's how continuous production changes everything. Because the United States has been building military aircraft every single year since 1941, and companies like Boeing and Lockheed Martin and Northrop Grumman have been designing and producing fighters and bombers and transport aircraft for multiple generations. And this means they have accumulated knowledge and refined processes and developed supplier networks that took decades to build and can't be quickly replicated. And think about what this expertise enables, because Lockheed Martin's F-35 production line builds over 150 stealth fighters per year with consistent quality and sophisticated automation. And this production rate is sustainable indefinitely because the factories and the workers and the suppliers are all optimized for this specific task. And compare this to other countries which build aircraft sporadically or in small batches, because Russia produces maybe a dozen Su-57 fighters per year, and Chinese production of J-20 stealth fighters is perhaps 20 or 30 annually, and European countries build even fewer advanced aircraft. And this production rate difference matters enormously, because it means American pilots can train on the actual aircraft. They'll fly in combat, while pilots in other countries often train on older aircraft because new ones are too scarce. And here's the compounding effect, because continuous production allows continuous improvement, where each batch of aircraft incorporates lessons from previous versions. And American fighters produced today are dramatically better than versions from 5 years ago, because the production line never stops, and feedback from operational use gets incorporated quickly. And compare this to countries that build a batch of aircraft and then stop production for years, because when production stops, the expertise dissipates, and workers move to other jobs and suppliers close, and restarting production is expensive and slow. And this explains why American aircraft production can surge during crises, while other countries struggle to increase output. And the second reason is what actually makes American aircraft technologically superior. And that's the massive investment in aerospace research and development that dwarfs spending by all other countries combined, and creates generational advantages in critical technologies. And here's why R&D spending matters so much for air power. Because modern aircraft are incredibly complex. Systems that incorporate cutting-edge technology in engines and materials, and avionics and weapons and sensors, and the country that leads in these underlying technologies produces superior aircraft, and the United States spends over $30 billion annually just on aerospace R&D for military applications, which is more than most countries spend on their entire air forces, and this money funds research into next-generation capabilities that won't see deployment for 10 or 20 years, and think about what this creates, because American research labs are currently developing sixth-generation aircraft with capabilities that sound like science fiction, including adaptive engines that change configuration during flight, and laser weapons and artificial intelligence that can pilot aircraft autonomously. And these technologies will create advantages that last for decades, because other countries are still trying to master fifth-generation capabilities that America deployed 20 years ago. And compare this to other countries which spend far less on aerospace R&D, because China perhaps spends $10 billion annually, and Russia spends maybe $3 billion, and European countries combined spend around $15 billion. And these smaller budgets mean they're always playing catch-up and trying to copy what America developed years earlier. And here's the mechanism that makes this decisive, because aerospace R&D compounds over time, where early investments create knowledge that enables future investments, and the United States has been outspending everyone on military aerospace R&D since the 1950s, which means 70 years of accumulated advantage, and this shows up in specific capabilities like stealth technology, where America developed radar-absorbent materials and shaping techniques in the 1980s, and still leads today, or advanced sensors that can track hundreds of targets simultaneously, or data fusion systems that integrate information from multiple aircraft. And here's why this advantage is sustainable, because cutting-edge aerospace research requires not just money, but also expertise and facilities and test infrastructure, and the United States has all of these, while other countries lack one or more elements. And the third reason is something that seems almost wasteful, but actually creates enormous advantages, and that's the American approach to building multiple competing aircraft programs simultaneously and letting the best design win. And this competition drives innovation faster than centralized planning. And here's how competition works in American aerospace, because the Air Force will often fund 2 or 3 different companies to develop competing prototypes for the same requirement, and then select the best one for production. And this seems expensive because it means paying for designs that don't get built, but it actually produces superior aircraft, because companies have to innovate to win competitions and think about specific examples, because the competition between Lockheed's F-22 and Northrop's YF-23 resulted in both companies pushing the boundaries of stealth and performance, and the winning F-22 incorporated the best ideas from both programs, and the same pattern applied to the F-35, where Lockheed competed against Boeing, and the competition drove both to develop innovative solutions. And compare this to other countries which typically select a single design early and commit to it, because Russia decided to build the Su-57 without competitive alternatives, and when problems emerged, there was no backup option, and China's J-20 was developed without competition. And this single-track approach means that if the chosen design has flaws, you're stuck with them. And here's the innovation advantage, because competition forces companies to take risks and try new approaches, because playing it safe means losing the contract, and this risk-taking produces breakthrough capabilities that conservative planning would never attempt. And beyond the direct competition between prime contractors, there's also competition at the subsystem level, because American aircraft use the best engines and the best radar and the best weapons regardless of who makes them. And this creates a market for excellence where component suppliers compete to provide superior systems, and the result is aircraft that integrate the best available technology rather than settling for what one company can provide. And the fourth reason is what makes American aircraft so effective in combat, and that's the integration with a global network of bases and tankers and satellites and early warning aircraft that create a system where individual aircraft are far more capable than their specifications suggest. And here's how the system works, because an American fighter doesn't operate alone. It's part of an integrated network where aerial refueling tankers extend its range indefinitely, and AWACS aircraft provide early warning of threats and reconnaissance. Satellites provide intelligence, and GPS provides precision navigation, and communication satellites enable real-time data sharing. And this integration means an American fighter operating over enemy territory has information and support that enemy fighters can't access. And think about what this enables, because during the Gulf War, American aircraft could see Iraqi aircraft taking off from bases hundreds of miles away, because AWACS provided complete air picture and American fighters could loiter over combat zones for hours, because tankers refueled them, and American pilots knew exactly where every threat was, because satellites and reconnaissance aircraft fed them intelligence. And compare this to other countries which have capable aircraft but lack the supporting infrastructure, because Russian fighters are excellent, but Russia has limited aerial refueling capability and fewer AWACS aircraft and less sophisticated satellite coverage. And Chinese aircraft operate primarily near Chinese bases, because China lacks global basing and has limited tanker fleet, and this limits how far they can project power. And here's the force multiplication effect, because the American system allows individual aircraft to achieve far more than their specifications suggest, and an F-15, with aerial refueling and AWACS support and satellite intelligence, can control airspace that would require dozens of unsupported aircraft, and the system also provides redundancy, where if one element fails, others compensate, and this robustness makes American air power sustainable, even under attack and beyond the direct combat support. There's also the maintenance and logistics network, because American aircraft operating overseas can receive parts and repairs through a global supply chain, and this allows sustained operations far from home bases. And the fifth reason is something that changed air warfare fundamentally, and that's the American investment in stealth technology, which makes aircraft invisible to enemy radar. And this creates first look, first shot advantages that are essentially unbeatable in air combat. And here's why stealth matters so much, because modern air warfare is primarily about detecting the enemy before they detect you, and shooting first. And stealth aircraft can penetrate enemy airspace without being detected, and this allows them to destroy air defenses and enemy aircraft before the enemy knows they're there. And the United States has been developing stealth technology since the 1970s and deployed the first operational stealth aircraft in the 1980s with the F-117, and has continuously refined the technology. And think about the current advantage, because the United States operates over 400 F-35 stealth fighters and about 180 F-22 stealth fighters and 20 B-2 stealth bombers, and this represents more operational stealth aircraft than all other countries have built, including prototypes. And compare this to potential adversaries, because China has perhaps 50 J-20 stealth fighters operational, and Russia has a dozen or fewer Su-57s, and no other country has deployed operational stealth aircraft. And this numerical advantage is compounded by technology gaps, because American stealth aircraft are stealthier, meaning they have smaller radar signatures, and this matters enormously in combat, because even a small difference in radar signature can mean the difference between detection and invisibility. And here's the tactical advantage, because in exercises where F-22s face conventional fighters, the stealth aircraft achieve kill ratios of 30-to-1 or higher, because they detect and shoot enemy aircraft before being detected themselves. And once you're fighting from a position of invisibility, the outcome is predetermined. And beyond fighter aircraft, the United States also has stealth bombers that can penetrate defended airspace and strike targets that conventional bombers couldn't reach. And the B-2 has conducted missions over heavily defended targets without being detected, and the upcoming B-21 will extend this capability for decades. And here's why this advantage is sustainable, because stealth technology is incredibly difficult to develop and requires expertise in materials science and computational modeling and radar physics, and even countries that understand the principles struggle to implement them effectively. And the sixth reason is what makes American pilots so effective individually, and that's the training system that provides more flying hours and more realistic exercises and more advanced simulators than any other country. And this creates pilot quality that multiplies the advantage of superior aircraft. And here's how American pilot training works, because fighter pilots typically get over 200 flying hours per year and participate in large-scale exercises like Red Flag that simulate realistic combat conditions and use advanced simulators that replicate enemy tactics. And this constant training creates pilots who can exploit their aircraft's capabilities fully. And think about what this expertise enables, Because an experienced pilot in an advanced aircraft is exponentially more effective than a novice in the same aircraft, and American pilots have so much training time that they can focus on tactics and decision-making rather than basic flying skills. And compare this to other countries where budget constraints limit flying hours, because Russian pilots typically get fewer than 100 hours per year, and Chinese pilots even fewer. And this reduced training means pilots are less proficient and can't fully utilize their aircraft's capabilities. And here's the compounding effect. Because experienced pilots are harder to kill and more likely to win engagements. And this creates a virtuous cycle where American pilots gain experience through training and combat, while enemy pilots get less training and die faster in combat. And beyond individual training, there's also the institutional knowledge, because the U.S. Air Force has been fighting continuously since the 1990s and has developed tactics and procedures based on real combat experience. And this knowledge is embedded in training programs and passed to new pilots. And the seventh reason is something that operates at the industrial level. And it's the American aerospace supply chain that includes thousands of specialized companies providing components and materials. And this ecosystem can't be replicated quickly because it represents decades of development and creates resilience and capability that integrated producers can't match. And here's how the supply chain works. Because a modern fighter aircraft contains over 300,000 parts from thousands of different suppliers, and these suppliers specialize in specific components, like engines or avionics or composite materials or hydraulic systems. And American Aerospace relies on this distributed supply chain where the prime contractor integrates components from the best suppliers. And think about what this enables, because it allows specialization where companies become world leaders in narrow domains. And Pratt & Whitney specializes in engines, and Raytheon specializes in missiles and radar, and Honeywell specializes in avionics. And each of these companies invests heavily in their specific technology. And this specialization produces better components than vertically integrated companies could develop internally. And compare this to countries that try to produce everything domestically because they lack the specialized suppliers and end up with inferior components. And Russian aircraft use Russian-made engines and avionics that lag American equivalents because the specialized supplier ecosystem doesn't exist. And here's the resilience advantage, because a distributed supply chain is harder to disrupt than centralized production. And if one supplier has problems, others can potentially fill the gap. And during crises, the supply chain can expand rapidly because many suppliers have excess capacity. And beyond the direct military supply chain, there's also overlap with commercial aerospace, because many suppliers serve both markets, and this dual use creates economies of scale and continuous innovation. And the eighth and final reason brings everything together, and it's the scale of the American defense budget, which provides resources to simultaneously fund aircraft procurement and R&D and training and maintenance at levels other countries can't match. And this financial advantage allows American air power to excel in every dimension simultaneously. And here's how budget scale matters. Because the United States spends over $200 billion annually on its air forces, including the Air Force and naval aviation. And this enormous budget allows buying over 100 new aircraft per year, and funding $30 billion in aerospace R&D, and providing 200 flying hours per pilot, and maintaining global bases and operating tanker fleets and fielding advanced weapons. And compare this to other countries which must make trade-offs because limited budgets force choosing between procurement and training, or between current capabilities and future development. And Russia spends perhaps $60 billion on its entire military and must allocate that across all services, and China spends around $200 billion total and must cover Army and Navy and Air Force. And these constraints mean they can't match American spending in every category. And here's the compounding effect. Because superior funding in one area enables advantages in others, and better training allows pilots to fully exploit better aircraft, and better aircraft justify higher procurement, which creates economies of scale, and continuous production enables continuous improvement, and the system reinforces itself. And when you combine all 8 of these reasons together, you see why the American Air Force is bigger and better than China and Russia and India and France and the UK. Combined because continuous industrial production creates expertise and capacity that competitors lack, and massive R&D investment produces generational technology advantages and competitive acquisition drives innovation faster than central planning and integrated systems, multiply individual aircraft effectiveness and stealth technology, provides first-look, first-shot advantages and superior training, creates pilot quality that multiplies equipment, advantages, and specialized supply chains, enable component excellence and resilience, and massive budgets allow excellence in every dimension simultaneously, and these 8 mechanisms work together in ways that compound over time because technology advantages allow smaller forces to achieve more, which justifies higher budgets, which fund more R&D, which creates better technology and production expertise, reduces costs, which allows buying more aircraft, which enables more training, which creates better pilots. And the result is an Air Force that's not just larger, but qualitatively superior in every meaningful dimension. And this dominance has profound strategic implications because air superiority is essential for modern warfare. And without it, ground forces are vulnerable and naval forces are exposed. And this means countries facing American air power must fundamentally rethink their strategies because conventional approaches to countering air power don't work against the scale and sophistication of American capabilities. And understanding these 8 reasons shows that American air dominance isn't temporary or vulnerable. It's the result of structural advantages built over 80 years and reinforced through continuous investment. And these advantages show no signs of diminishing because American aerospace companies are already developing next-generation capabilities, and the budget remains enormous, and the training system continues producing superior pilots, and the industrial base keeps churning out advanced aircraft. And this is why the American Air Force is bigger than multiple major powers combined and will likely remain so for decades, because the mechanisms that created this dominance are still operating and actually growing stronger.